Welcome back everyone to my YouTube channel. In this tutorial today we are going to learn about scale factors, and when we see the little r, we're talking about our scale factor here. Now if we look at this first image, which is wxy, and we're seeing that w is equals to w prime and x is equals to x prime, y is equals to y prime, that is telling us that this figure is the same, and because the figure is the same, then our scale factor there is going to be equals to 1. So the image did not change. But when we see this second figure where we see w prime, x prime, and y prime is actually larger than our original figure, which is wxy, we know that the scale factor here is going to be greater than 1. And in the third figure, our wxy is this one, regular one, and our w prime, x prime, and y prime is our smaller figure. So then here we know that our scale factor is going to be less than 1. It is smaller. So now another thing that we need to know about scale factors here, it's usually associated with dilation, and dilation is not a rigid motion. Now because the three basic rigid motions are reflection, rotation, and translation, because they preserve angles and they also preserve the segment lengths. Now with dilation, the reason why it's not a rigid motion is because only the angles are being preserved. The segments either get larger or they get smaller. So in this case, you see the segments here would be getting larger, and the segment in this other figure here, the segment would be getting smaller, meaning that r is less than 1. You can have a dilation of a scale of a quarter or a half, and you could also have a dilation of 2 or 3. Now I will do another video on how to actually construct a dilation in relation to the given scale factor. But now we're going to focus on questions that I know you will always see on an exam that has to do with scale factors, how to calculate your scale factor, and how to find the missing or unknown segment, dilated segment, given the scale factor. Or even if you were not given the scale factor, how to calculate and apply it to this segment. So that was the basic gamut of what scale factors are, right? And so there is also a formula to find scale factor, which is r. So we're going to say r, and I'm going to write it in different color. R is, which is our scale factor here, it is equal to our dilated segment, segment over the original segment. Okay, that's what r is equal to. Now you can look at this figure here. It says to find y prime, z prime, and yy1. This is yy1 we need to find, the unknown, and this is the other unknown we need to find, y prime, z prime. Now we are given here this basic triangle here, which is triangle XYZ. We're given the dimensions of that triangle, and based on this we can find our r scale factor. First thing we have to do is find the scale factor. So because we know that the scale factor is a dilated segment over the original, our dilated segment here would be our xz prime. All right, and that would be 8 plus the 4, which is 8 plus 4 here, which is equals to 12. So r, because we have the dilated segment over the original segment, we have, which this is going to give a r, is going to be 12 over original segment, which is just our xz, which is 8. And we can further reduce this. So r, x is going to be equal to 4 into 12 is 3, and 4 into 8 is 2, so further reduced to 3 over 2. So our scale factor there is 1.5, or we keep it as a fraction, 3 over 2. Now we need to apply that, and we need to find the y prime z prime. So in order to find that, we have here our segment YZ, because this original figure XYZ is dilated and it gets larger to X, Y prime and Z prime. X, Y, we're going to apply the dilation formula to it to find this segment here, Y prime, Z prime. And another way of saying the original segment, also we can write it another way, and we can say the original segment, use a different color, original segment is simply equal to the dilated segment right here. Once you look at this, then everything will be fine. Is your original segment that you have here, and if in other words, for you to find this, you know that if you have your original segment here, right, it is going to be equal to the dilated segment divided by R. Or you can also say that your dilated segment, all right, dilated segment is going to be R times the original segment. So that's another way to rewrite the scenario. Depends on what is given to you. You can use either one of these three formulas to arrive at your answer. So now we are given here, we have YZ is equals to 9, right? And that is our original segment. So we can write OS beside it so we know. And then we want to find our dilated segment. So we can use this formula, and that's that one. We know our dilated segment is equals to a scale factor times our original segment. So a dilated segment, which will be Y prime Z prime here, would equal to the scale factor of 3 over 2 times 9. And so Y prime Z prime is equals to 9 threes is 27 over 2, because let's pretend this is over 1, 9 over 1, and you cross multiply, right? That's another tip I have to show you, how to multiply whole numbers with fraction. And so Y prime Z prime is equal to 13.5, or you can say 13.5. Okay, so that's what we have for Y prime Z prime. Now we need to find the other one, okay? And I'm going to do it right here. So we need to find, we already find Y prime Z prime. We need to find Y prime. That's this little segment right here. So what we're going to do, we know that we have our dilated over original. So we have this dilated here, which is our dilated over original. All right, and we can talk in terms of that. We can have our dilated, which is 12 over 8 for a scale factor, set it equals to x y prime, which is our dilated on this part. That will be this side. Okay, and our original would be xy here, which is 7. Okay, so this is our, the 12 would be our xz prime over our, this 8 would be our xz. All right, so 12 over 8 equal x prime, xy prime over xy, which is 7. All right, we can cross multiply this, and when we cross multiply, this is basic, math. We cross multiply when we are working with proportion. So we have 8xy prime is equals to 7. 12 times 7, which we know is 84. So xy prime is equals to 84. 8 of that. We divide both sides by 8. and we are going to get a fraction. Yep, we're going to get a fraction there. And with that fraction, we have 84 divided by 8 in this case, and 84 divided by 8 is 10.5, because 8 times 10 is 80, so you have 10.5 here, or 10.5. Okay, so that is just your x y prime, which is 10.5 here. Now, to get the value of this, all right, meaning y prime, y prime is equal to, right, you have your entire segment, which is your dilated segment, which is x y prime minus xy. So xy prime, y prime is equals to xy prime, which is 10.5, right? Xy prime, which is 10.5, minus 7. So let's move this up so you're able to see. Sorry. So now you have y prime is equals to 3.5. All right. And you just box your answer. And if you want to check your work, all I suggest you do also to check your work here is simply, let's flip this way, and check your work. You can check it over here, and you can do dilated, which is your 10.5 over your original, which is 7. Okay, and set it equal. See what is set it equal to the next segment, because this is your dilated, which is 10.5, right? Your original is 7. Set it equals to any one of these. You could choose your 9 over your 13.5. All right, your 9 over 13.5, and you cross multiply it. 9, sorry, your dilated here will be the 13.5 on top. 13.5 over 9, and cross multiply these, then, and these two, you cross multiply them, you will end up with 13.5 times 7 is going to give you 94. So 7 times 13.5 is equals to 9 times 10.5. So you're going to get 94.5 here, and the other one you will get for that side, which is the 9.5, sorry, 9 times 10.5, you're going to get 94.5. Now the number on the right is equal to the number on the left. Yes, and that's how you check your work. Once you get the number on the right is equal to the number on the left hand side, then yes, your answer is correct. Okay, so that's it that we have for scale factor for today. Just remember, it is associated with dilation, and dilation is not a rigid motion. Only the angles are being preserved, but the segments either get larger or they get smaller. Bye now, and see you on the other side.